Hello, you're welcome to this lesson. In this video, you are going to solve this question I have on the screen. The question says the assembly consists of a 4 kg pulley and a 10 kg pulley labeled A and B. If a 3 kg block is suspended from the cord, determine the block speed after it descends 1.5 meters starting from rest. Neglect the mass of the cord and treat the pulleys as thin discs. No slipping occurs. So let's look at how you are going to solve this question. To solve this question, you are going to apply the energy conservation equation. So you are going to have the initial kinetic energy plus the initial potential energy to be equal to the final kinetic energy the final kinetic energy plus the final potential energy. So this is the equation we have now. So in this case, you don't have any loss of energy here. The question didn't say that, and also there are no spring elements in this system. So you are going to exclude elastic potential energy and then energy loss. So this is the equation you have now. Okay, so what I'll do is that I'll draw a datum at the initial position of the block. Okay, then that will be position 1, then its final position will be position 2, and it traveled or descended a distance of 1.5 meters. Okay, so initially it was at rest, so for that reason the whole system will be at rest since the block was at rest. So you're going to have the initial kinetic energy to be 0. Okay, and then if I consider the datum to be at the position 1, okay, which is this point here, then that means that the initial potential energy will be 0. Okay, that's the potential energy of the block will be 0. So we have 0, 0 here. Okay, so let's look at the final kinetic energy. So for the final kinetic energy, since the block will be descending, there's going to be motion. Okay, so we have to find the kinetic energy. Okay, so in this case, because the two pulleys will be rotating, okay, because the two pulleys will be rotating, you're going to have rotational kinetic energy. So we are going to sum up the rotational kinetic energy of the two pulleys in addition to the translational kinetic energy of the block. Okay, so let's look at what we are going to get. So you're going to have 1 over 2 IA multiplying omega A squared, okay, plus 1 over 2 IB multiplying omega B squared. Then put all this in one bracket, okay, plus the translational kinetic energy of the block, which will be half mv squared. Okay, then let's look at the final potential energy. So at first the block was at position 1 and then it descended a distance of 1.5 meters to position 2. So its potential energy will be mg times the distance it descended. Okay, but since acceleration due to gravity is negative, you are going to have minus mg times the distance descended, which is 1.5 meters. Okay, so this is what we have now. So before we continue, let's look at something here. We know that linear velocity equals angular velocity times radius, right? Okay, but in this case, you've been told that no slipping occurs. Okay, so what that means is that the rope is not going to be slipping from the pulleys, which means that it is kind of attached to the pulleys. Okay, so for this reason, the linear velocity at any point on the rope will be equal for both pulleys. Okay, the linear velocity at any point on the rope will be equal for both pulleys. So you are going to have the linear velocity v, okay, which will be the final velocity, to be equal to the angular velocity of pulley A times the radius of pulley A, and this would be the same as the angular velocity of pulley B times its radius, okay, because there is no slipping. They are all going to have the same linear velocity at any point on the rope, which is the final velocity v that we have here. So what you're going to do is that you're going to make the angular velocities the subject. Okay, so you're going to have omega A to be equal to V over R, and then omega B to be equal to V over capital R. Okay, so you substitute these expressions into the previous equation. Okay, so let's look at that. So you're going to have 0 equals 1 over 2 multiplying IA. Okay, multiplying IA times omega A squared, which is now V over R squared. Okay, plus 1 over 2 IB multiplying omega B squared, which will now be V over capital R squared. Okay, plus half MV squared minus mg multiplying 1.5. Okay, so the IA and IB represents the mass moment of inertia. Mass moment of inertia. And we've been told to consider the pulleys as a thin disc. Okay, so for this reason, we're going to have the mass moment of inertia to be equal to 1 over 2 multiplying m multiplying r squared. Okay, this is the expression for the mass moment of inertia. So you're going to have mass moment of inertia for pulley A and pulley B. So you're going to have IA to be equal to half MA, okay, half MA r squared, and then IB to be equal to half MB r squared. Okay, that should be capital R, capital R. Okay, so that's what we have now. Okay, so what you do is that you are going to substitute this, expressions in place of IA and IB in the equation we have. Okay, so let's look at that. Okay, so you are going to have 0. Okay, 0 equals, let me bring a square bracket. Okay, and I'm going to have 1 over 2, 1 over 2, oh, let me write this again, square bracket, okay, and then 1 over 2, and then multiplying IA, right? So IA is now 1 over 2 MA r squared, right? Okay, times V over R all squared. Okay, this is what you are going to have for this expression here. Okay, for this expression here, this is what you have now. Okay, so now let's do same for the second term here. So you're going to have plus 1 over 2 multiplying 1 over 2 MB r squared, okay, multiplying V over R all squared. Okay, let me close the square bracket. Okay, so I'm going to have plus half mv squared minus mg multiplying 1.5. Okay, so let's do some simplification here and see. So you're going to have half multiplying half, which will be 1 over 4 ma, and then because I'm going to square this term here, because I'm going to square this, you're going to have r squared, and that will cancel out this r squared here. Okay, so let's take note of that. So for that reason, you're going to have MAV squared. Okay, this is what we will have, plus 1 over 4 MBV squared. Okay, plus half MV squared minus mg multiplying 1.5. Okay, so what you have to do next is that you have to make v the subject, because that's what we are supposed to find. Okay, that's what you're supposed to find, so you have to make it the subject. So you see that it is common to the first three terms here. It is common here. We have v here, we have v here, we have v here. So you just have to factor it out. Okay, so let's go ahead and then look at that. Okay, so if you are factoring v out, you're going to have 0 equals, let's do it this way. I'm going to have v squared, okay, multiplying 1 over 4 MA. Okay, this is what you're going to have, plus 1 over 4 MB. Okay, plus 1 over 2 M. Okay, minus mg multiplying 1.5. Okay, so this is what you have now. So what I'll do next is that I will send this term here. I will send this term here to the right hand side. Okay, so let's look at that. So you're going to have mg multiplying 1.5 to be equal to v squared. Okay, v squared multiplying 1 over 4 ma plus 1 over 4 mb plus half m. Okay, this is what we have now. Okay, so now you are going to divide both sides by this whole term that we have here. Okay, so let's look at that. Okay, so I'm going to have, I won't write this again, so let's just write it as v squared equals mg multiplying 1.5 divided by 1 over 4 multiplying ma plus 1 over 4 multiplying mb plus half m. Okay, so this is what we have now. Okay, so at this point, what I want us to do is that we should substitute in the known values, okay, so that it will be easy for us. So we know the mass of the block to be 3 kilogram, right? So you are going to have 3 multiplying acceleration due to gravity, which will be, let's do it 3 times 9.81 times 1.5. Okay, this is what we have. Okay, divided by 1 over 4 into bracket ME, which is 4 kilogram, okay, plus MB, which is 10 kilogram, okay, plus half M, which is 3 kilogram. So this is what we have now. So now let's simplify what we have. So I'll punch the term or the value you have on top on the calculator and see what you have. So I have 3 times 9.81 times 1.5. Then that gave me a value of 44.145. Okay, so all this divided by 1 over 4 multiplying 14 plus 1 over 2 multiplying 3. Okay, so when I do this, I'll get 5. So this is what you have. So now you have v squared equals, let's divide 44.145 by 5. So 44.14145 divided by 5. That gives us a value of 8.829. Okay, so now let's take the square root of this value, 8.829, and then that gives me an answer of 2.97 meters per second.